All right, guys, welcome to the Unit 3 Test Study Guide. I'm going to be doing the even problems. The odd problems are there for you to practice with if you want to. The answers for the odds are provided. That way you can check your work. So the idea is that if you don't know how to do the even problems and you had to come watch the video, I would encourage you to go back and do the odd problem that matches it and see if you got it right the second time. But that being said, we'll go ahead and get started here. So we want to know for numbers 1 through 4, does the data represent a function? So what is a function? A function is a relationship between x and y where each x has only one y. Okay, so does each value of x have only one y? Well, when it comes to looking at a table, you could tell by looking at the x column and seeing if there's any repeats. See how that x value is a repeat? That means that the value of x equals 4 has two different y values. So if x equals 4, you get 1. But if x equals 4, then you get -2. So the answer is no, that's not a function. So the shortcut is if x has repeats, then it's not a function. But if x doesn't have any repeats, then it is a function. Okay? Now I want you guys to understand the y column can have repeats and it can still be a function. That doesn't matter. What matters is you cannot have any repeats in the x column. Now for numbers 3 and 4, the way that we could tell if it's a function or not is by doing what's called the vertical line test. If you can draw a vertical line and it touches your curve more than once, then the answer is no. So, since it touches twice, or we could say touches more than once, then that means it's not a function. And the reason for that is because for this value of x, at x equals 3, there's two different y values. At x equals 3, we have a y value of 2 and also a y value of -2. And every x can only have one y. So for tables, the shortcut is just see if the x row has any repeats. If it does, then it's not a function. For graphs, the shortcut is just draw a vertical line. If it touches it twice, then it's not a function. But if it only touches it once, then it is a function. All right, let's go ahead and continue here. We'll go ahead and take a look at number 4. So at number 4, they give us a function, g of x equals 3x minus 4. And they want us to find g of 8, now g of -8. That means I'm going to replace the x value with a -8. And from there, we're just going to simplify it. -8 times 3 is -24. And -24 take away 4 is -28. And so g of -8 is equal to -28 as a final answer there. All right, so for number 6, it's a little bit similar to number 4, but it's a little different also. So let's see what the similarities and differences are. On this one, you'll notice that the number that they give you is not plugged in here. What this means is that f of x equals 24. So I'm going to replace this entire thing here with 24. Not x, but I'm going to replace the f of x with 24. And it looks like that. For these ones, you have to go through and do some math to solve it as a result. So I'm going to have to add 3 first. And then I'm going to divide by -3. I'm getting -9. All right, so now let's go ahead and take a look at number 8. So for number 8, they give me two functions, f and g here, and they're asking me to find this expression. So apparently they want me to take the f function, they want me to multiply it by 3, and then subtract from it the g function. Okay, so what does the f function equal? Well, the f function's up here. Apparently the f function is x cubed plus 5. So I'm going to replace the f with x cubed plus 5. Same thing here with the g. I'm going to replace the g function with what g equals. G seems to equal 4x plus 2. From there, we're just going to simplify. So to simplify, the first thing we're going to do is we're going to distribute. And when you have a subtraction sign, you do have to distribute that as well. And what that does is it changes the signs of everything in the parentheses that it's being distributed to. Then you want to combine your like terms. Now, like terms are terms that have the same variable and exponent. So for instance, there's only one x cubed here. So that's going to stay the same. Not going to do anything with that. There's also only one x term here, just an x to the first power. So that's going to stay the same. But these two are just both numbers. We can combine those together. So that would be 13 when if you do 15 take away 2. And so there's our final answer for that one. So for number 10, they give me a function. And they want me to find this. And what that means is I want to replace the n with 3n. So you're going to do that on the other side of the equation as well. Instead of having a negative n plus 1, I'm going to replace the n with 3n. And so it becomes negative 3n plus 1. Sometimes you'll have to simplify these, but in this case there really wasn't much to do, so it stayed about the same. So for number 12, I give you two functions, f and g, and I ask you basically, what kind of transformation is g compared to f? Well, by putting a negative in front of it, that is something that will cause your graph to flip upside down. And so that would be a reflection across the x-axis. So for instance, if f looked like this, then g would look like this, like it gets flipped across the x-axis. That's what happens when you have a negative outside the parentheses there. Let's take a look at number 14. When you add a number inside the parentheses, that causes your graph to shift to the left 2 spaces. So in other words, if f looked like this, then g would be shifted 2 spaces to the left, and it would look something like that. Okay? Let's go ahead and take a look at number 16. So on this one, they give me the function f of x equals x squared. And what they've done is they've subtracted 1 on the inside. Now when you subtract 1 on the inside, that causes the graph to be shifted to the right that many spaces. So in other words, if f looked like this, then g would be shifted 1 space to the right, so it would look something like that. On number 18, we have something being multiplied in the parentheses. So when it's inside the parentheses, that's going to be a horizontal effect. If it's outside the parentheses, then it's vertical. But this is inside the parentheses, so it's going to be horizontal. Now, whenever you multiply by a number that's less than 1 inside of those parentheses, what it's going to do is it's going to expand your function. Now, some of you guys might be wondering, where are we getting all this information from? Well, all this stuff is coming from 3.3 through about 3.6 notes. Okay? So we have some little charts that I gave you to help you know all the different transformations and how you can tell what they are. So I would say, if you're wondering, how do I know all these things? Look back at your 3.3 through 3.6 notes and you can see. Let's go ahead and take a look at number 20. So I've got a number outside the parentheses multiplying there. So that's a vertical transformation. Also, it's a number bigger than 1, which means that it's going to be an expansion. So we have a vertical expansion. All right, let's go ahead and take a look at 22. Now 22 has multiple transformations on it. Well, it has more than one anyway. So first of all, we're multiplying by a number that is smaller than 1 outside the parentheses. So since it's outside, it's vertical. And since it's smaller than 1, it's going to be a compression. So we have a vertical compression. But we also have a negative outside the parentheses, and that is a reflection across the x-axis. So we're looking for which option has a vertical compression and a reflection across the x-axis, and that would be option D there. Another way we could ask these questions is by doing, by looking at the actual graphs. Okay, let's go ahead and start here. Here's my graph of f. I want to know what would this one look like if I put a negative on the outside. Well, we've talked about how when you put a negative on the outside, what that's going to do is it's going to cause your graph to flip upside down. So it would look like that. So we're going to look at our options here below, and we're going to find which one looks like it's just been flipped upside down, and that would be option G for number 24. Okay, let's take a look at another one. Let's take a look at number 26. On 26, what would happen if I subtracted 2 on the outside? That's going to move your graph down 2 spaces. So if I took this shape and I moved it down 2 spaces, it would probably end up looking something like that. So let's go ahead and look at our options and see which one looks like it's been shifted down 2 spaces. I can see it already here. It's option D. Let's go ahead and take a look at number 28. When you subtract a number on the inside, that shifts it to the right, and it's shifting it to the right 2 spaces. So that would look something like this if I were to shift it over to the right 2 spaces. And I can see that that's option B there. Let's take a look at number 30. I'm multiplying on the outside, so that's a vertical transformation. And since it's half, which is less than 1, that's a compression. So that's going to shrink my graph vertically. So in other words, it's going to look flatter. It's going to look maybe more like that. So let's see where we could find the parabola where it looks kind of flat. Well, that looks like option H to me. All right, let's take a look at number 32. So now we're multiplying by half again, but it's inside the parentheses, which means it's horizontal. Now with horizontals, when you're multiplying by a number that is less than 1, that's actually an expansion. So what that's going to do is it's going to stretch my graph out so it looks wider. It'll still be just as tall, but it'll just be wider. So we're looking for a graph that is wider. And that looks like it would be option I. Let's go ahead and check out number 34, our last one. Or I guess I should say our last one for these types of problems anyway. All right, so let's take a look here. First of all, I've got a negative inside the parentheses that I'm multiplying by a negative. So that's a horizontal reflection. It's a reflection in the y-axis. Okay, so in other words, it's going to take this shape and flip it over the y-axis. So if I did that, it would look something like this. Okay. Also, I'm multiplying inside the parentheses, so that's horizontal, by a number less than 1, which is an expansion. So I'm expanding it horizontally as well. So now not only is it flipped to the other side, but now it's going to be wider. And then finally, I'm shifting it up 3 spaces. So we're going up 3 spaces. So if I were to shift that shape up 3 spaces, then it would probably look something like this. All right, so let's go ahead and see if we can find one that is close to that here somewhere. That looks like option F. All right, and so those are your transformations. All right, and then we get to the review portion of our test. These are all questions from Unit 1 and Unit 2. So if you wanted to look at your notes to kind of prepare for these, you could do that. So we want to graph the line, okay? So this is y equals mx plus b, all right? Oops, didn't want to do that. Now this number here is your y-intercept. That's where it touches the y-axis. This number here, that's my slope. And it's best to think of a slope as a fraction. So I'll think of that as negative 2 over 1. Now that tells you your rise over run. But here's the thing. Since it's negative, it's not going to be a rise. It's actually going to be a fall. So it's a drop over 1 because of the negative. So when you want to graph a line, the first thing you do is you plot your y-intercept. So I'm going to go up 2 on the y-axis. Then I'm going to go down 2 and right 1. Down 2, right 1. And put another dot. And there's the graph. Okay? So if you want to review that stuff, I would say take a look at Unit 1 notes. Look at our first unit notes. Let's go ahead and take a look at number 38. So number 38 is another graphing question, but we need to fix it first. It's not in graph-ready form. We need to get the y by itself. So the first thing I'm going to do is minus the 5x on both sides. Next thing I'll do is divide everything by a negative 3. You get 5 over 3x minus 3 as a result. And now we're ready to graph it. My y-intercept is negative 3, so I'll start 3 down on the y-axis. My slope is 5/3, so I'm going to rise 5 up 5 spaces and over 3. Put another dot, so rise 5, run 3, and then connect those two dots, and you're good to go. All right, moving on to number 40. This is another question from Unit 1. Writing the equation of a line. Okay. To find the equation of a line, we need to start by finding our m value. And the way that you find m is by using the formula y2 minus y1 over x2 minus x1. This is x1 and y1, and this is x2 and y2. And we just plug those into this formula here, and we'll have our answer, for the slope anyway. It's not the end of the problem, but it's the most tedious part. So y2 minus y1 over x2 minus x1. Watch out for these double negatives here, because those become positives. Negative 3 plus 5 on the top there becomes 2, and the bottom is 3. So there's my slope. The next thing we want to do is we want to find our b value. The way that you do that is by taking your y equals mx plus b equation, and you're going to plug in y1 here, x1 here, and slope here. Now you could plug in x1 and y1. You could also plug in x2 and y2. It doesn't matter which pair you plug in. I'm going to pick the 2's this time. So let's do that. Negative 3 is my y2. My slope that I found in my first step is 2/3. My x2 is 0. And we're ready to solve. Now 0 times 2/3 is 0. And then 0 plus b is just b, so we have b equals -3. And then the final thing we do is we actually go ahead and write out the equation of the line. So that would be y equals 2/3 x minus 3. So we're finding the equation of a line. Step 1, find your slope using the slope formula. Step 2, find your b value. Step 3, write the equation. All right. Step 4, we're going to use substitution to find the solution to the system of equations. Now this is in your Unit 2 notes, so if you want to look at that, take a look at your Unit 2 notes. It's in there. But basically what you do is you find the letter that's by itself. It says y equals. Circle what it equals and plug that in for y into the other equation. So instead of -3x minus 6y equals 15, we're going to replace the y with what y equals, which is that. We're going to go ahead and distribute here. And then we're going to solve. So these two combine to make 15x. And then we're going to subtract 120 on both sides. And that's -105. And then we're going to divide. And what does that equal? 30, 60, 90. I'm going to say that equals -7. -7. All right. Now the problem's only asking me to find the x-coordinates, so I'll stop there. That's my answer. But if you wanted to find the y value, what you would do is you would plug it back in. You'd plug in -7 for x, and then you could solve for y. All right, but I'll stop there because we only want the x value. Let's go ahead and move on to the next question, number 44. Another system of equations, but this time they want me to do elimination. All right, so once again, this is in Unit 2 notes, so if you want to see your notes on this and have it there to help you, you can bring those with you on the day of the test. Here we go. So what you're going to do is you're going to pick a variable that you would like to cancel out. I'll go ahead and pick the x's because the numbers are smaller. And what you're going to do is you're going to take the numbers that are in front of the x's, you're going to reverse them. So the 3 is going to go on the top now, and the -4 is going to go on the bottom. And we're going to multiply those all the way through. And that's going to create a new pair of equations for me. The top will now be -12x minus 30y equals 30 plus 24 is 54. The bottom is going to be -12x plus 80y equals 40 plus 16 is 56, so -56. Okay, our next step is we want to multiply everything on one of the equations. We want to multiply one of those equations by a negative. So I'm going to multiply the bottom one by a -1. And basically what that's going to do is it's going to change all the signs. The top equation is going to stay the same, so I'll just rewrite that really quick. The bottom equation, all the signs will be opposite now. After that, we're good to go ahead and add these things together. So -12x and +12x cancel when you combine them. The -30y and the -80y becomes -110y. And the 54 and the 56 also becomes 110. So if we divide, we get 110 divided by 110, or -110 that is, and we end up with y equals -1. Now the problem is asking us to find the x-coordinate, so I've got the y-coordinate, but I do want to find the x-coordinate. So how do we find the x-coordinate? Well, now that I know y equals -1, we just go back to one of our equations, and we replace the y value with what we just got. And then from there, we'll go ahead and solve. And there's my final answer. Okay, and that's the elimination method. All right, so hopefully that was helpful, guys, and we'll see you guys in class for your test. I'll see you then. Bye-bye.